Hi, I'm Jonelle.
And I'm David. We are both opera singers and mentors with Opera in Reach, but today we're going to be scientists.
So, you just heard and saw Jaclyn singing an operatic aria. True or false? She is using a microphone to amplify her voice. False.
How is she able to sing so loud without a microphone?
Opera singers can be heard because of something called resonance. No matter the volume of our singing, the sound will be amplified.
Let's take a minute to discuss why opera singers don't use or need microphones.
Opera is an art form that has been around for over 400 years, but microphones weren't invented until the late 19th century. So, for centuries, opera singers have trained their voices and bodies to naturally amplify their voice to be heard over orchestras and in concert halls.
Here's the thing. No matter the volume or dynamic marking indicated in the music, an opera singer's years of training ensure that their voices are able to be heard and amplified. How do they do this, you ask?
Resonance, that's how.
So what is resonance and how does it occur? When we sing, air comes out of our lungs and into the larynx, also known as the voice box. As the air passes through the larynx, it gets compressed by the vocal folds, causing the air molecules to move faster. Think of when you put your thumb on the end of a garden hose. The stream begins to spray. Faster air carries the sound waves created by the vibrations of the vocal folds, but that's only the beginning.
Most objects have what is called a natural frequency. Have you ever tapped on something and heard a pitch? That sound or pitch you hear is its natural frequency. This is especially clear in objects that have an empty space within it, which can be referred to as a container. Let's try it out. Tap on an object and hear the pitch it makes. That's its natural frequency. Resonance also allows you to use the room as a microphone. Concert halls and opera houses are often designed in many ways to help the sound travel, but also to help the sound resonate. So the places you normally hear opera also have an impact on how effective our resonance is. Singing in spaces with hard surfaces or dome-like ceilings are usually ideal, versus singing in a venue with softer fabric-covered surfaces.
Each musical pitch you hear is actually made up of a series of pitches, most of which are hard to distinguish. These pitches are called overtones, and the pitch most distinguishable is called the fundamental. The overtones occur in an exact pattern over the fundamental, but based on what container they are resonating in, certain overtones are amplified over the others.
Since we are all genetically unique and our bodies are all shaped differently, we all have different overtones resonated, giving us our unique sound to our voices.
So, how can humans be heard over the instruments?
Though both humans and instruments can create the same musical pitch, humans are able to access and resonate a specific overtone that instruments cannot. That overtone can actually be distinguished by the ringing sound you hear in an opera singer's voice. Your brain recognizes this sound and draws your attention to it. At the beginning of the video, we heard Jaclyn singing a portion of an aria, a song from an opera by Strauss. Her voice would be heard clearly above an orchestra of 40 instruments because of the overtones she can access as an opera singer.
That's amazing!
Thank you for coming to our session today. We hope you enjoyed it.
Thanks! Now, enough talking about singing. Let's hear some actual singing. Take it away, Jonelle.